Okay, today in class we talked about transformations, so we're going to describe the different types of transformations. So before we do that, we're going to talk about what it means to be congruent. This is when two shapes have the same shape and exactly the same size. They are exactly the same. So I have a picture of three parallelograms. All three of these are congruent. The symbol that we use for congruent is that little squiggly with the equals below it. And we would say these are all congruent if you notice that this one has been rotated and it's flipped on its side. So it's still congruent even though it's not in the same direction, but it does have the same shape and the same size. Similar is when two shapes are the same shape but not necessarily the same size. So same shape but their size does not have to be the same. So here we have the same parallelogram, but we have a smaller one and we have a larger one. They're the same shape but they aren't the same size, so we say they're similar. Our notation or what we use to show similar is just the little squiggly. The squiggly with the equals, remember, is congruent with just the squiggly. It means they are similar. So example 1 says to determine whether the shapes are congruent or similar. On the ovals, they are not the same size, so we would say they are similar. Our triangles are exactly the same shape and size, so we say they're congruent. Our trapezoids, the purple ones, are exactly the same shape and size. One is just rotated, so we say they are congruent. Our rectangles on B are not the same shape. They are the same shape, not the same size, so we say they're similar. Our suns,
could you please come to the front office?
Sorry about that. Our suns here are not the same size, but they are the same shape, so we say they're similar. And then our X's are the same, one's just been rotated, exactly the same, they are congruent. Okay, our pre-image is what the original image is called. I always say it's the image we begin with. The image that we end with, or the new figure, is what we call the image. Transformations, these are, they change the position of a shape on a coordinate plane. A shape is moving from one place to another. There are three basic transformations. One is a flip, which we call a reflection. A slide is a translation, and a turn is a rotation. I'll give you examples of those on the next few slides. So here, a reflection is a transformation that flips across a line or over a line. So if this was our line here, if we flip that over, it would look like this. Our next shape, if we flipped across this line here, we would get this shape. A translation slides, so we're either sliding, we can slide over and up. We can slide back. There's lots of directions that we can slide. Okay, so here it's going to slide in that direction, so it gives us the exact same orientation, shape, and size. Here it's sliding, it would be sliding down and over to give us the shape here. So it went down and over. A rotation, it turns through a specific angle. So this is going to flip upside down to give us the shape here. The next one's going to go, if it goes upside down, we say it's 180 degrees. The next one is traveling, not quite 180. It doesn't flip all the way over. So we'll become very specific about those angles. A lot of times we'll do 180, 90.
Teachers, if you haven't approved.
Sorry about that. All right, so or we have 270, and those will probably be the major degrees of rotation that we will talk about. Okay, so example 1 says describe the type or types of transformation shown in the figure. Here we can either say it has been reflected over that the y-axis, so we can say we have a reflection. Or you can see that it's been slid over, so what we call a slide is a translation. B has been flipped over, so we can see that it has rotated to that side, or we call it a rotation or a turn. Okay, and the last type of transformation is called a dilation. This is a transformation that may change the size of a figure. What we did in class is we turned off the lights and we looked at our eyes, and we flipped the lights back on to see how they dilate and they get larger and smaller, and we call those, first of all, an enlargement. When our shape gets a lot bigger. When the shape gets smaller, like on the next one, we call it a reduction. And you notice that these two shapes are similar. All of their previous transformations, our image is always congruent to the pre-image. On a dilation, they'll be similar. They can be congruent, but most likely they will be similar. And we have what's known as a scale factor. This is the amount of change for either an enlargement. If it's greater than 1, it's an enlargement. If it's less than 1, it's a reduction. And we'll spend more time on all of these. We'll probably spend a day on each of these transformations. So that should help you with your 8-1 transformation worksheet. Good luck.